Well, welcome to the video and to the channel. I'm working on a Tascam 122 Mark III. This is a deck that I've already completed. It's been a full overhaul, and in the testing I had good Wow Flutter numbers while the deck was still cold, but after 15 or 20 minutes and it got warmed up, the numbers went high. They doubled, or roughly. Of course, this isn't acceptable. This deck's going in a professional environment, and this is the second one that I've done for this customer. Fortunately, he had a backup spare parts deck, so we decided it would be worth it to remove this one, overhaul it, and swap it with the one that's having problems. So he pulled the transport and sent it to me, and this is it. Fortunately, this one is actually in much better condition motorboard wise. It has not been tampered with. It looks like it's original factory. And like I said, the other one, I'll show it here in a minute, the other one had been tampered with a lot. I've done these a few times on the channel in complete form, and so I plan to fast forward through most of this. It's redundant information, however, I think it's still interesting, and I get a lot of questions on these and a lot of comments and a fair amount of views, so I don't think it's wasted to film it and upload the procedure and the results. So this is basically just a matter of removing that set of springs, 2 springs, and then that one bracket, and the door will pop off, and that will expose that front capstan assembly nut that needs to come out. Now these, I don't think I've ever taken one apart that isn't slightly loose. This one's not slightly loose. This one actually is relatively tight compared to the ones I see most times. You'll notice when I replace these, I put a little drop of blue Loctite on those threads because I've seen so many of them that loosen up. I'll clean up the front part of this capstan shaft with a little IPA before I pull it through the bearings, so I don't pull through whatever. This is pretty clean, but still good habit. And I have never run this motor, so I just want to see if I can get a pulse out of it before I start. Give it about 5 volts here, 4 or 5 volts. No, not making contact here. I still think this is the easiest way to get to it. Okay, it's got a heartbeat. Excellent. We'll proceed as planned. I'm still kind of deciding whether to replace just the board or replace the whole assembly, and I'm leaning towards the assembly because the other one, like I say, it's been tampered with quite a bit, and that could indicate that there's been wear problems, and this deck it looked like it was pretty worn. It had been very well educated, let's say. And apart from this motor problem, it's excellent now. You can see this is all factory stuff here. I don't think anything's been touched on this. The original paint seal is still on that end plate screw, and it's not cracked. So I'm hopeful. Like I said, I've done these several times on the channel before. Maybe I'll see if I can put a link or two, or a card, I should say, up here for maybe one or the other of those. I have different ways of doing this. This board is in extremely good condition. I don't see any sign of leakage. I don't see any damage to the traces. And so I think what I'll do on this one is just use the 2 iron method to remove these. Sometimes if I see damage or suspect damage, I'll clip them off, and I've shown that in other videos. I'll clip them off and then remove the parts. And I think there's probably a little less stress, certainly fewer heating cycles that way on the pads. And so I think it's a good method if I suspect that there's a possibility of those pads lifting. This looks to be in excellent condition, so I think I'll just pop them off this way. I'll fast forward through this. Kind of, if you've seen one, you've seen them all. Of course, I fluxed everything up first. In my shop, I like to follow the procedure of removing all the old solder and scrubbing it with solder wick. It's worked well for me. It's a kind of a known good way to do things. This is the brand and the type I prefer. And that little bit of abrasion from the solder wick, I think, especially in the case where these have been corroded, it really helps get them clean. If you've seen some of the other videos, you'll see there are places that even after I've gone through all this and fluxed it, I've still had problems with it tinning, still had problems with a pad tinning. And that's, that's the corrosion that happened from the leaking capacitors. So okay, let's fast forward through this. And maybe I'll put another card here to one of the other recaps. Yeah, these are all coming off really nicely, so like I said, I didn't anticipate having problems with this one. kind of soak these down with some IPA. Not really liking this swab. It's breaking down really quickly. But really all I'm doing is just getting a bunch of fluid on here. Like I missed one there. I'll go back over it here with a new one that I know doesn't break down so quickly. Contamination, fibers from Q-tips and things like that can contaminate these joints, and so these are great for cleaning up, but I always like to go back over it with foam swabs and compressed air and make sure that there's no fiber contamination in those joints. I have reasons for this. I've actually seen it cause problems in the past, so I like to be clean. Okay, let's get some new foam swabs. Just go back over them quickly, make sure it's as clean as I can get it. And then just blow it off with compressed air when I'm done with this. Okay, I'm also going to clean my solder. Same thing, IPA, and this is why. This is all really important. You'll see now why and how quickly these pads will tin when they're that clean. And you'll also see me clean the iron in between each solder job. So really I'm trying to stay off of these pads. I'm trying to not heat them up very much. That's the point. And also to get a, to get an uncontaminated joint. I don't make this, I didn't make this procedure up. This is something I learned from people that do this sort of thing. Okay, I've got my capacitors selected, cleaned. I clean the legs on them, and then I tin them, and then shape the leads with a wire bender so that they have a nice radius in them. I also, for the most part, try to buy the smaller case capacitors, since they're available. They're not available. I've never found them for the C12 and C14 bipolars, but all the rest of them I can get the right values for. So I just tack the one leg and then get the other leg seated. So I'm putting pressure down on it and keeping the pressure on until it freezes. And the purpose is to make firm contact with the pad, not to have the leads floating in the solder, but to actually have them down on the pad. So that's what I'm doing here. And then I'll just go back and just build it up a little bit. Of course, these pads aren't designed for through-hole capacitors, but I've had very good success with this procedure, and a lot of other people have too. So and there's those smaller case, I should say. Yeah, I think I'll show one more and then fast forward through the rest. Maybe this one will be a little bit more visible. Okay, so just tack it. That's all I'm doing, just tacking it there. Okay, get this one seated. And then add a little bit more. Hold it down while it freezes. And then do the other one. Like I said, I do get quite a few questions about these and the capacitor values and so forth. So I think I'll just put them right here. You can pause it and write it down or whatever you'd like to do if you need this information. Now this would apply to the Mark II as well. So the 122 Mark II and 3, I believe the 238, and possibly one of the other multi-trackers, maybe the 234, I can't remember for sure, and possibly others, but at least these. Okay, so that's my procedure on these. And I've had at least 2 of them on my own running for, probably 11 or 12 years. And at times they've done a lot of archiving, run many hours at a time, and have been just very stable all through the whole job. All right, so let's get the board off. See what it looks like inside. And this looks good, very typical. Nothing's cracking, none of the potting compound is breaking down. Thrust bearing grease is pretty dark. That can actually happen from not being used as well. It just absorbs moisture out of the atmosphere and turns hard. I actually think it works better when it's used. I don't think it goes to turns to glue so quickly. Obviously been balanced. So just by the appearance of this, I've already decided to go ahead and overhaul it rather than piecemealing the other motor. This one is in considerably better shape than the other one was. So let's just take a couple of comparison measurements here. I'll check the inductance and the resistance on these coils. I'll see if I can put another card here. I don't know how many cards they'll let me put in, but I've been working on manufacturing these coils. I think this is a good sample to measure. It seems to be in very good condition. They also look to be very consistent, so that's a good thing. Let's have a look at this. Oh no, that's not right. Yeah, there we go. Okay, I'm satisfied with that. Clean it up here. This is RA solder or flux, so I need to dissolve it and clean it off the board. And soak it down here and blow it off. Okay, I just want to check the balance on this capstan since I'm going to go ahead and overhaul this motor assembly. I've always found, at least the ones I've worked on, the Tascam ones that I've tested, have been very consistent and always have been pretty good. So I'm using this piece of paper just to space it, because you can see it's just such a tiny amount of overhang on that shaft on the inside there. Would be a really bad thing to have that work its way off and damage my stand. Okay. Not bad so far. Whoops. And that's the reason the stand has to be made out of a non-ferrous material. All right, let's try this again. Okay, so you can see they've removed the material from exactly the right spot, seemingly. I realize this doesn't really provide the most interesting content for a video, but this is the procedure. This is what I go through. And I think some people like to see it. I don't know. But I have a camera and a channel, so I'm filming it. So let me show a little bit of this and what I'm doing and how I'm doing it, and then I will fast forward through the remainder of it. But I will show it because I think it's important that it's known, you know, how much time goes into a little balancing job like this. Okay, so my heavy spot is 180 degrees opposite this mark. And I'm just going to check that a few times. And it looks like those balancing marks are in direct line with what I perceive to be the light spot. So first, I will remove a little bit more material off of that mark right there, and I'll just use a deburring tool for this. I'm taking off grains, and very few. If any way possible, I'd like to not overshoot this one. It is in the right spot. It just needs a little bit more material taken off. So I'll sneak up on this a little tiny bit at a time. So that's the tool I'm using right now. So I'll take a little bit of material off, and then I'll blow everything off again. And that's how much I took off. It's very little. Put it back in. And I can see now that every time I do this, the paper is shedding a little bit right on that knife edge. And I should be wiping that off every time. Just darken that up so that the camera can see it a little bit better. This is probably balanced close enough. It's certainly within, a factory spec. But I'm here, I've got it apart, everything's set up, and so I'm going to proceed and get this dialed in as close as I can. So I'll fast forward through this, try to not bore you too much. In the end, I spent about maybe 35-40 minutes doing this. But I'm also really happy about where it came out. And see, I'm moving over a little bit, kind of walking it over, removing a little bit more, a little bit more. And like I say, those balancing marks ended up being in exactly the right spot. I just needed to take a little bit more material off than what I was doing. Starting to get there. Now, of course, at this point, I'm really starting to get a feel for how this thing's reacting, and I've kind of got it dialed in to what I think is, I'm kind of anticipating what's happening, and it's working because I've been on this stand with it now so long, I kind of know where it's going to bottom out. All right, so now I think I've got it where I'm happy with it. And I should be able to put this in any, I should be able to clock this in any rotation, in any spot, and have it stay in that spot. Even rocking it back and forth, it should remain, within a small amount. And you can see it's no longer returning to that mark. It's staying put. And I'm going to call that done. Okay, so back at the bench, let's get our bearings cleaned and lubed. I don't like to wet clean these with hot solvents. I just put a little bit of acetone on the toothpick, and then I kind of look at the toothpick and see if any debris is coming off of it. And following that, I like to dry brush it. And then most importantly, blow it out with compressed air and remove any of the debris from the space in between those two bearings. And then we'll get a little oil in it. I'm using the Isoflex PDP 65 that I get from Peter over at Nagravox. And that's worked out really well for me on these. And I've also got some of the Otari oil from American Recorder. I believe that's where I get that. And I believe that's the PDP 68. But I use this for the cassettes. It seems to be the perfect thing for it. Okay, so we'll just get a couple drops in there and let it sit. Then do it again before I assemble it. Now, just for a point of interest, if these get to the point where they're just no longer serviceable, I can replace these. I can machine new oil-light bushings. I also have other higher tech materials, but this is still probably the best for this application. It's not inexpensive, but if it's a job that needs to be done, it can be done. Okay, let's get this thrust washer out and cleaned and re-lubed. Yeah, there she comes, and that is black, hard oil in there now, or hardened grease. There it is. Get this old grease cleaned out. And wow, that is not coming off easily. I may have to just soak this for a while and let it sit. Yeah, it's not coming out. It's hardened up there and stuck to the brass. I just don't want, when I relube this, I don't want the new lubricant to loosen that up and break down, and then the little flakes becoming part of the grease. Yeah, I think I better. I think I better just soak it for a minute. Okay, well, that's soaking. I'll remove the other transport that is getting the transplanted motor. And of course, like I said, I've already finished this one, and so it's all tied up and wire wrapped, and it will be a little more difficult to get out than when everything was just loose. But that's okay. We'll do whatever I need to do. So again, just to recap, the problem here was that when I first started up, and for the first 10 or 15 minutes, the deck would run Wow Flutter at about 0.04, hovering around 0.04, which is the spec on this deck. And then, because I always get some hours on these before I send them back to the owners, I discovered that after, like I say, 10 or 15 minutes, the Wow Flutter numbers started increasing, and they would stabilize at somewhere around 0.08, 0.09, hovering around there. And that's just not operationally acceptable. So I contacted the owner. He had told me that he had a parts deck, and he removed the transport, sent it to me, and then, so you see, I've rebuilt the motor, and now I'm going to place the rebuilt motor in the already overhauled transport and see if we can get those numbers down and back into spec, and hopefully, maybe, possibly better than spec. Generally speaking, on one that's not completely worn out, I can hit spec or better on these. So I have to be a little bit more careful with this one because everything's, like I said, everything's already completed and tied up, and if possible I don't want to have to redo much of that. So same thing, springs come out, door brackets removed, and then the I guess they call it a beauty plate, but it's actually a shield. Help shield the tape from the motor's magnetic fields. Okay, I just need to get access to the nut. I have to cut a couple of these off. That's okay. There, that's all I need. I know you can't see it too well, but that's all I need. And you can see that I have to put a little bit more force on that because I did blue Loctite these in. And I have to continually back it out too. It doesn't just roll out. All right, so in this case, I'll just leave all the wiring in place. And there it is. Finally got this all cleaned up. And here's the product I use on it. The Krytox GP205. Also sometimes I'll use the 207. Sometimes I'll also use Lubriplate 3000. Any of these will be a lifetime lubricant. This won't ever need to be done again. If it ever gets taken apart, I would do it again, but this will be lifetime service. I think it's obvious the dimple on the thrust washer faces the capstan, mates to it. And it is important to get the lube on both sides so that that thrust washer is free to move. All right. Let's tidy up the rest of the assembly now. I just like to make sure that these screws are torqued down while I'm in here. Yeah, that all looks really good. I do a lot of dampening and isolation and shielding on particularly this model. And one of the things I like to do here is to just isolate the motor from the transport a little bit. And this is just the urethane tape on this side and the nut side. And that seems to be really stuck down there well. From now on, I'll be laser cutting these instead of manually cutting them or stamping them. On this particular model, I like to isolate the transport from the chassis and then the motor from the transport. And I've had good success with this. It's one of the things that, you know, I put it in that category of, you know, what Tascam should have done. And so I have a procedure for doing this, and it's worked out well. Also do some additional shielding and some additional vibration dampening. Okay, I think we're all cleaned up here. Just give it one last cleanup. Try to get it way down at the very bottom there where the outside bearing rides. I'm sorry, the inside bearing. And again, blow it all off. Part of the dampening work on these is applying some heat shrink to these brass posts just to help deal with the resonance on a long, thin piece of ringy material. I've shown this before on other videos. Speed through this part and get to more interesting things. Alright, let's clean the old solder off of these lead ends and retin them. Got one last drop of oil in there. I forgot, I like to put just a drop of grease on that on that end flank. This doesn't, in operation, this doesn't ever touch that. This is strictly for shipping and, you know, any sort of hard movement when that whole capstan pulley might overcome the magnetic force and slam up against that back bushing. That's all it's for, is just to provide a little cushioning to it. And that is ready to go. All right. I like it. Let's show you these two side by side. Now the one on the right there, it may be one of the aftermarket replacements. I'm not sure. It kind of looks like it. I'll have to research that. And maybe if the owner's willing, I can experiment with my replacement coils on this motor, since it's really not suitable for use the way it is. I'll just finish it up here. Let's have one more look. And what I'll do is clean that, any oil off of that capstan, and then I'll remove my custom oil seal off the old one and put it on the new one. Unfortunately here my card filled up and I didn't capture the footage, even though the camera was running, of the reassembly of all this. It sure be nice if they'd put some kind of a tone on when you were getting to 50 megs or something of space left, just to let us know that our cards are running out of gas. Anyway, here it is. It is back together. Just to put the door back on and place it back in the chassis and get some tests done. really hope this takes care of this Wow Flutter issue on this machine, because it turned out exceptionally nice. I mean, not only does it sound good and make a good recording, but aesthetically it looks fantastic. It came in not looking so good. It had stickers on it and a bunch of scratches and things like that, but I put a lot of work into making it look nice, and it looks brand new. And so I'm particularly pleased with this build. Now let me see if I can shine a light in here so we can see our first startup. And kind of in a shadow here, but there it is right there. You can see I'm hitting the leaf switch to activate the capstan, and it is spinning. Doesn't look like it's overspeeding. I'm going to put a tape in it and let it run for a few minutes. Change the cameras around and start up the sound technology and run some tests. Okay, I've got a few minutes on this now. I'm going to put my homemade Wow Flutter tape in this before I put my expensive one in. And let's see how she does. Okay, hoping you can see up there the number that's moving around. It looks like with the homemade tape, it's hovering around 0.03332. And this is first startup, so maybe 5-10 minutes of runtime. I can pretty much sense that it's running well, so I don't mind putting my reference tape in. And of course, this one has a lot of dropouts in it, but when I do find a good section in the tape, I trust it. Okay, I'll let it settle in here. Okay, so pretty similar to the homemade tape in this, in this universe of randomness. There's a spike, and then it'll come back down. That spike is a dropout. Okay, so this is bettering the spec. Let me swap this around one more time and change the camera so that you can see the face of the deck, and then we'll run some tests at the beginning and middle and end of the tape, and I'll let it run here for 30-40 minutes before I do those tests. Okay, so I've repacked my RCA tape, and I'm going to run it at the beginning of side B. These are full track recordings, and so side B on this one is much less used than side A. You can see in the meter how much it's fluctuating. and that's just wear. Okay, we'll get it off of the very first part. Let's see, what am I missing here? Oh, it might help if I hit the input. Okay, so this is the beginning of the tape. Okay, so hovering around that 0.033, and again the spec on this deck is 0.04. Okay, so let's forward this to somewhere around the middle of this tape. Right about there. Okay, maybe just a little bit better in the middle of the tape, kind of what I would expect. Kind of dipping down into the 0.2 range. Okay, I like that. Let's take it to the end of the tape. Couldn't quite see that from my angle. Okay, I'm liking this. I saw a 0.024 there. So all this is hovering down below the factory spec. So it's bettering factory spec, and that makes me happy. I also expect it on these. I just test the speed here, running a little bit fast. So while I'm here, I'll just set that to give me a reference. I will get quite a few hours of runtime on this deck before I return it to him. And I'll go through all this one more time and reset the speed, although he's perfectly capable of doing this and actually has much more modern equipment than I have. These trim pots are so touchy on these, and I wish... I really need to come up with a modification on them so that I can put 25 turn trim pots in them. I've done it on a few decks. It's been a good thing. But this one, I haven't found a direct replacement for it. It's just the wrong configuration and not enough space. Looks like I ran out of... I was right at the end of the tape on that, so... So the upshot of it is, I'm pleased with this. I think the replacement motor was successful. It's going to get, like I said, many hours of runtime, and then I'll check it through again. I'll see if I can make another video showing the final results of all of it. And maybe the owner will allow me to experiment with the other motor and see if I can't replace the coils and make some more tests. Not on this deck. I have plenty of these that I can test my own with. But there we are. Of course, I'm very pleased he had a parts deck that we could rob this motor out of. I've kept an eye out on the usual sources to try and find another motor, another transport, maybe an inexpensive deck, damaged, broken, whatever, to buy. And they're not out there. The price on these is increasing every time I look. And it's reasonable. I mean, the price of everything's going up, but I think the demand is going up also. And because these were built as a studio and, radio studio deck, the ones that you do find a lot of times are really worn out, because they would turn these things on in the morning and let them run all day long. And so I'm happy with how this turned out. I know he'll be happy, and we'll see how things pan out here in the new year. Maybe keep an eye out for another video with the final results on this machine. So thank you for watching once again. I wish us all a successful and, God willing, peaceful 2025. We'll see you soon.